Today may be very quick. We're going to finish this up and then I'm going to go over the unit circle with you. Tomorrow and Wednesday, you will work on another packet and then we'll go over it Thursday and Friday. Remember, we have 2 weeks left and then you have Memorial Day and then you start your first period exam. Second period exam will be on Wednesday. And you do have to come to school for that. Is everybody good? All right. So number 16 is a drag and drop. So you match it, you would drag this to wherever it needs to go. So what I would start with, it says, please click and drag each interval into the column that describes the function on that interval. So we have decreasing, increasing, positive, and negative. And if we look, all I'm going to do to begin with is just highlight these intervals for you. So your first interval is -4 to -1. So that's this one. Your next interval is -2 to 0. And I know that it overlaps. I try to make it look like it overlapped or whatever. And then I have 0 to 2, which is here. And then 0 to 4, which is to there. Okay. All right, so then we're going to look at this. What does decreasing mean? Goes down. So there's only one part of this graph that goes down, and that's right in here. Does everybody understand that? So the reason I highlighted it was so you could see it a little bit better. If you look at the pink, it increases on the left side and decreases on the right. So this one is not fully decreasing. So it can't be the -4 to -1. But if you look at my orange line, it is completely decreasing, and that is the -2 to 0. So that's what you would drop there. And remember, they do have the highlight tool on your test, so you can use it just like that. Okay. Your next one, it says increasing. That means it's going up. It's going up. So which one is continuously going up? Yeah, the green from 0 to 4. What's that bracket mean? Sorry, because this should not be a bracket. What's the bracket mean? It's a closed point, means it's included in the interval. Good. All right, positive. Positive, just so you know, would be above the x-axis. And negative would be below the x-axis. Okay. So we've already ruled out the orange and the green. We're only looking at the pink and the blue. So which one is above the x-axis? The pink, the -4 to -1, which makes the blue 0 to 2 below the x-axis. Does everybody see that? So you know increasing and decreasing, that's easy. The positive and negative might have been weird. It's got to be above or below the x-axis. Any questions on that one? It's a really easy question. Please don't miss those. Okay, really easy question. All right. I think we did 17. Go to 18. This one says which function does not have the set of all real numbers as its domain, meaning it doesn't have a whole or an asymptote or anything crazy within that domain. And the best way to do this is to graph it. And I'm going to jump over here and try to, please go away, little thing. Get Desmos up so you guys can see it. Zoomers, I'm just trying to find Desmos. I'm going to stop sharing this and share Desmos. So we're going to start with the first one. And I'm going to do y equals 5 to the x, get out of it, minus 3. Okay. So does not have the set of all real numbers. So it does, sorry, it has to have an asymptote or a whole. If we look at this, does it have an asymptote or a whole? So does it stretch all the way from left to right? That's what we're looking for. This doesn't stretch all the way left to right. Yeah, so if we put arrows on the end of those, okay, if we put arrows on the end, they're going to continually go left and right. What are they not going to do? What are they not going to do? What's this graph not going to do? No. Speaking of domain or range, what is it not going to do? Is this graph 100%? Domain is negative to positive infinity. We got that. Is range. Why? What's that got to do with anything? And I don't mean that in a bad way. Tell me. Explain it. Thank you. It can't go below -3. So it does have an asymptote, but it has it in the range. So that's where watch your wording. Okay. This one says the set of all numbers has its domain. So this domain is okay, but if it changed it to range, would it be okay? No. Does everybody understand that? Watch your wording. All right. So this one's good. This one's not your answer. The next one is x plus 1, bless you, over x plus 3. What about this one? Does it continually go to the left and right? Does it? Okay, so we're kind of questioning this one, right? Let's check out the other one. So if we get a little confused, check out the other ones. All right, so let me check out the next one. Y equals absolute value 2x minus 1. Does this one continuously go left to right? Yeah. This is another one where the range would not be all reals because it doesn't drop below the x-axis. Everybody see that? So watch that wording. So this one's okay, so it's not your answer. So right now we've eliminated A and C. All right, so we haven't really looked at trig functions because most of the trig functions that you do in this, you're gonna be able to just put in your calculator, okay? So trig functions come from more from math 2, but we can do a little bit in math 3. So we did cosine. I'm gonna see if it'll work this way. Yes, it did. Just typing it in. I didn't do anything weird. Does this one go left to right the whole time? Yes. So all three of these do, which means the one that I was questioning, do you think it goes left to right? Tell me what you think about it now. X plus 1 over x plus 3. Tell me what you think about it now. Why would it not go all the way left to right? So I'm going to stop this sharing and go back to my paper for a minute. Remember when we had these? If I give you an example of something like this, x plus 1, x plus 2, x plus 3, x plus 2. This is just an example. This has absolutely nothing to do with this problem other than like a little teaching moment. Remember, anything the same on the top and the bottom we can mark out, and that causes a hole. Does everybody remember that? So that'll be a hole at -2. When we leave something in the denominator, that's a vertical asymptote. That means it doesn't touch that x. So x cannot equal -3. So we have a vertical asymptote, which means a jump or a gap. That's that point of discontinuity. So it definitely is B. But if I wasn't sure, I could have still gotten this problem right. Does everybody see that? Because I could have eliminated A, C, and D. Okay, so don't stress out about it too much. And again, with Desmos, it'll plug that right in. So don't worry about that cosine. And I literally just typed it in, COS parentheses X. Okay, you didn't have to go to the functions or anything. All right, we did 19. I want to hold off on 20 and 21. And I think we did 22, so we're good. All right. think we're at 25 now. All right, so 25 is this. The reason I'm holding off on the other ones, the first one is with the unit circle, and we're going to go over that today. And the second one is some weird period, amplitude, blah, blah, blah. You'll do more of that in pre-cal, so it's more of a pre-cal question, so I hate that it's even in this, but I'll show you how to do it, okay? So triangle PMT is shown below. And remember that this means that these two are the same angle, these two are equal, these two are equal. And then we have some 90 degrees here, so those will help us out as well. All right, so it says measure of GH, and I always just go ahead and put those in. GH is this line is X plus 3. PG is 4X plus 1, and GJ is 2X minus 1. It says, what is the measure of segment PG? Can anybody see anything that you could do to solve this problem? What does it look like? What would you do? If you got this problem on the test, we haven't done any triangles like this. It's math too. We haven't done any triangles like this. What do we do? What would you do to solve this problem? You tell me. Come on, guys. Your test taken in a week and a half. A week and a half. 2 weeks-ish. Tell me what you got. What would you do on this problem? Zoomers, anybody, give me an idea. How do you think you start? You don't have to. It's even easier than that. Why? Girl, you own it today. Right here. You guys see this? This triangle is the same as this triangle. Did everybody see that? So what she said is these two have to be the same. And they are. They absolutely are. So we're going to set those equal. 2x minus 1 equal to x plus 3. That is the absolute right thing to do. Good job. We're going to solve it. We're going to subtract x. We get x minus 1 equals 3. We're going to add 1 and x equals 4. Now, if you look at your answers, this is what I need you to understand. They did not ask you for x, but they're always going to put it there. Does everybody understand? Make sure. It says, what's the measure of PG? PG is 4x plus 1. X was 4, so 4 times 4 is 16 plus 1 is 17. Very, very good job. Any questions? 25. Again, don't make it harder than what it is. Don't overthink it. They give you a lot of junk that you don't need, okay? 27. David plans to cover the floor of his room with new material. The floor is an isosceles trapezoid. What does isosceles mean? Two sides are the same, okay? What's a trapezoid? Give me an idea. Draw in the air, I don't care. What's it look like? And the other two kind of go into each other. What I call it is a triangle with the top cut off. Does that make sense? A triangle with the top cut off. So I'm going to draw that for you guys. And then I'm going to put those two little marks to remind me that they're exactly the same. Okay. The floor is an isosceles trapezoid whose bases are 16 and 26. What are the bases on this thing? Yeah, the top and the bottom. 16 and 26. The sides are 13. Each piece of new material has an area of 2.5 square feet.
Assuming the pieces of the new material can be cut as needed, how many pieces does David need? How many does he need? So what do we got to find? Yeah, the area, right? So area of a trapezoid. How do we do that? If you do not know the area of the trapezoid, you can split this thing up. You can split it up. What can you split it up into? Triangles and a rectangle, right? Do we know area of a triangle? If you had Troy, it is base height divided by 2. If you had anybody else, it's 1/2 base times height. Isn't that weird? That's how I know who you had when you tell me that formula. All right, so I don't care which one you do, that's fine. And then area of a rectangle is length times width, right? All right, so I'm going to split this up because I don't know the area of a trapezoid. I know it, you may not, that's okay. So if the top is 16 and the bottom is 26, this is going to be 16. And how much would I have left over? How much? 10, but I have 2 triangles. So how much is each triangle? 5 and 5. Problem is 13 is not the height of my triangle. So how do I find this height? What kind of triangles are these? Right triangles. So how do I find the third side of a right triangle? A squared plus B squared equals C squared. You can absolutely do it that way that you just said, just because you did it all in your head is perfectly fine. So in my calculator, because I'm lazy, just like he said, 13 squared minus 5 squared gives me 144. So B is 12. So my height is 12. All right. So just finding the area of the trapezoid. We have 2 triangles plus 1 rectangle. Take it back to elementary school. You told triangle was base height divided by 2, or I do 1/2 times base times height. It doesn't matter. For your triangle, your base and height are 12 and 5. For your 1 rectangle, your length is 16, your height is 12. Just to throw this out here, your 2's will cancel out. 12 times 5 is 60. 16 times 12 is 192. Add that up. And we get an area of 252. Now look at your answers. You guys see that that's on your answer, right? That's not what it asked for. That's not what it asked for. So it says, assuming the pieces of new material can be cut as needed, how many pieces? Each piece is 2.5 square feet. So how do I figure out how many pieces I need? 252 divided by 2.5 gives me 100.8. So how many pieces am I going to need? Good. Guys, I'm going to tell you, one day you're going to get old and you're going to do something like this. My husband have done it. We've done it multiple times. We like to lay tile in our house. How much tile do we need without going over? Because I don't want to spend a bunch of money on this. That makes sense? How much carpet do we need? How much paint do we need? I don't want to spend more than I need to. So these things are going to come up in your life. All right. Any questions on 27? 28 is good. We did 29. And we did 30. All right. We will come back to all those other ones. Zoomers, I don't have you a blank unit circle on your canvas. I hope I have enough for everybody in here. I don't think I do. I'll get you one. I only have 3. I'll get you guys a copy. Just give me a minute. All right. So I'm going to fill this in and put it on there. I will add a blank copy to Canvas as soon as possible. I'm going to teach you guys how to do it, and then I'll go back to, I'm sorry. I thought I had enough, but I only have 3. I don't know where they all went because I definitely had more than 3 up there. unless they're internet, I don't see them. So I will make you some copies, but I'm gonna go over it and tell you exactly how to find everything. Okay. So when we look at this, I'm gonna stop sharing here. I'm gonna look it up. You guys can also look it up. It's not a big deal. I might have a unit circle on your stuff somewhere in there. All right. So I'm going to flip back and forth and show you guys how this works. So since it's called a unit circle, this is not right. I'm already messing up. It's literally based off of one unit. So if we were on a coordinate plane with this, we would go over 1 and up 0. This would be like your x-axis. Does everybody understand that? Okay. So then what would this one be? What would this one be? Say it again. Because I went over 9 and up 1. What would this coordinate be? How far over would I go? Negative 1, 0. And then down here, what would this one be? Perfect. Any questions there? All right. So if we're talking about this circle, your degrees on this circle are going to be 0 or 360 when we make the full circle all the way back around. Okay. Is everybody good? What would this degree be? Think about it. From here, 90. So then what would this half circle degree be? 180. And how would I figure out this bottom? You could do 360 minus 90. You could do 180 plus 90. It doesn't matter. Sorry, let me get 360. And what do we get? 270. All right. I'm going to make this a little more visual for you guys. Did I even get the, hold on, I don't think I got the right one. I did on this one. This one doesn't have one. Sorry, it's this one, that's why. Because you can't see it. Ignore this one. All right. So these are cutting it in halves. Okay, so think about a pizza. I'm going to have 4 slices. So if I cut it in half, half of 90 is 45. And then we have 90, and we go halfway again. So 45 more gives me 135. Plus 45 gives me 180. Plus 45 gives me my 225. Plus 45 gives me my 270. Plus 45 again gives me 315. Plus 45 will give me my 360 or back to 0. So all of those, think about it as slices of pizza. You can cut it into 4ths or halves or whatever, 1/3. All right. The other ones are based on 60s or 30s. Okay. So this one's going to be 30 degrees. The next one is going to be add 30 more. So what's 30 plus 30? Plus 30 is 90. Plus 30 is 120. Plus 30 is? Do you guys do 30, 60, 90 triangles? No, not in math 2. It's an honors. So if you had math 2 honors, you should have done 30, 60, 90s. So here's your 160 plus 30 is 150, not 160. I'm sorry, y'all. Plus 30 is 180. Plus 30 is 210. Plus 30 is? Plus 30 is? Plus 30 is? Plus 30 is? 330 plus 30 is 360. Does everybody get? Now, when we do the next one, I'm going to show you where they come from. I'm going to show you you guys will see it. So you see how this is pi over 6, pi over 4, pi over 3. You're going to have to be able to do this. So this first one was pi over 6. All right. So I'm going to flip this over for Brent. I'm going to show you. It was 30 degrees. How do we get 30 degrees into pi over 6? You have to know how to do this, and always wait till the final exam to teach you this. It's really simple. Your pi is on the top. You guys see that? So you're either going to do a multiply by pi over 180 or 180 over pi. So here's the difference. We're going from degrees to radians. We're going to multiply by pi over 180. If we're going from radians to degrees, we're going to multiply by 180 over pi. That's one of those questions that I said I have to do the unit circle before I tell you. Okay, and you'll see this come up again. So here's what I'm saying. You're going to take your 30 and to put it into radians, you're going to multiply by pi over 180. See how it gives me this crazy decimal? This is why you have to know how to do this. I can't do it. I can do it in my calculator, but I'm going to stick with just numbers. See how it gives me 1 over 6? So this is 30 pi over 180. Your 30 over 180 reduces to 1 over 6. If I want to go the other way, pi over 6, and I want to turn it into degrees, I need pi's to cancel out, so the pi has to go on the bottom. So that's always how I think about it. If I want it to cancel it out, it has to be on the bottom. So these cancel out. And then we just have 180 divided by 6, which is 30 degrees. So these two formulas you need to know. Okay, so everybody got it? All right, so we're going to flip it back. So 45, you're going to do 45 divided by 180, and you get 1/4, and you just put a pi on top of it. So pi over 4. Okay, I'm going to minimize it so you guys can see it a little bit more. So 60 divided by 180 gives us 1/3. We put a pi on the top. See how easy it is? All right. 90 divided by 180 is 1/2. So this one is pi over 2. 120 divided by 180 is 2/3. Put a pi on the top. It's the same exact thing. Don't change it at all. 135 divided by 180, math, enter, is 3/4. Put a pi on the top. 3 pi over 4. 150 divided by 180 is 5/6. 5 over 6. Put a pi on the top. 180 divided by 180 is just 1. Put a pi on the top. Usually they don't put 1 pi, they just put pi. Super simple, right? Everybody got it? All right. 210 divided by 180 is 7 over 6. Put the pi on the top. 225 divided by 180 is 5 over 4. Put a pi on the top. 240 divided by 180, math, enter. Let me get 180 on there. Is 4/3. Put a pi on the top. 270 divided by 180 is 3/2. So 3 pi over 2. 300 divided by 180, 5 pi over 3. 7 pi over 4. 330 divided by 180 is 11 over 6. So 11 pi over 6. And then on this one, 360 divided by 180 is 2 or 0. So if it's 0 degrees, it's 0 pi. Obviously, you didn't go anywhere. Or 2 pi. Any questions about degrees and radians? Everybody good on those? I'm going to hold off on your coordinates. We're going to work on degrees or radians. Don't be surprised if you see this come up at some point, okay, where you have to fill it in and turn it in. It's real easy. I told you can just look online as well. But you're going to have this on your final exam. So can you make it from your final exam? So far, yes, you can, okay? So your degrees are really easy. Let me go over it one more time. You understand 0, 90, 180, and 270, right? Okay, 360 is a full circle. Everyone closest is 30 degrees. Everyone that splits it into fourths. So think about a pizza again, the fourths are going to give you the 45s. So 0 to 90, that's half of it's 45. 90 to 180, half of that is 135. So everybody see that? Everything else is based off of 30s. Is everybody okay? All right. So again, we're going to hold off on the coordinates. The easy ones are the ones that I already put. I will go over those coordinates tomorrow to give us something else to do. Any questions? All right. So I'm going to stop there for today. I want you guys to upload everything or every notes that we took. I also want you to upload the unit circle, this unit circle. I'm going to give you guys a copy so you can take a picture. Zoomers, I'm going to put you one on there, but I only want it to look like this. Does everybody understand? So I'm going to know if you didn't watch this video. I'm going to know if the Zoomers don't watch this video because I want the unit circle to look just like I left it in our notes. Got it? And then if you guys want to look it up after you upload and do the rest of them, I'm going to show you how to get those coordinates tomorrow. Everybody okay? All right. So I'm going to stop sharing, stop recording. I don't think I shared with you guys and no Zoomer told me, so that's fun. So Zoomers, here is the unit circle that I did so that you guys can go back. And that's the one that I want turned in. So right here, here's your top half and your bottom half. That's all we really did. I don't know that I can get it all on there at one time. So again, coordinate up there at the top. Make sure you have all the other stuff. And that's what I want turned in. All right, so I'm going to stop sharing